This lesson is on complex fractions. This is an example of a complex fraction. It's a fraction where the pieces of the fraction are also fractions. What we'll want to do is simplify. It's not considered simplified to keep it in a form like this. Here's the strategy for simplifying complex fractions. There are a couple of methods to doing it. I'll only do one. To simplify a complex fraction, perform the following steps. Find the LCD of all fractions within the complex fraction. Multiply the numerator and denominator of the complex fraction by the LCD. Then simplify the result to lowest terms. For the complex fraction, determine the LCD of all the fractions appearing within the expression. X over 5 minus 1 over 6 all over 2 over 15 minus 3x. This doesn't appear to be a fraction, but we could write it as a fraction as itself over 1. Now I'm looking at 5, 6, and 15. We'll find the LCD of these the same as we've done in the past. 5 is just 5, 6 is 2 times 3, 15 is 3 times 5. We list the factors that occur, and then we'll use them the most number of times they occur in one set. 2 shows up once here, not there, we'll use it once. 3 shows up once here, not there, so we'll use it just once. 5 shows up once here and here, but not here, so we'll use it once. When we multiply that together, we get 30. So the LCD of all the fractions appearing within this expression is 30. With this problem, it looks a little more complicated, but you just need to recognize that the denominator is a binomial. And these have denominators of 1. So it's easy to see here that the LCD is going to be x plus 1, x minus 1. For this problem, we have 3 different denominators. None of them have any common factors with each other, so all of them together will be the LCD. Let's simplify the complex fraction using the method that we had outlined above. This is 2/3 over 5/6. The LCD of the little denominators, 3 and 6, is 6. What I'll do is multiply by 6 over 6. Remember, this is the same as multiplying by 1, and it doesn't change the value of the fraction. So now I have 2/3 times 6 over 5/6 times 6. Then I can cancel. 3 goes into 6 2 times. 6 cancels 6 completely. And I have 4 over 5. In this example, the little denominators are 14x and 7x. Can you see that the LCD is 14x? If not, we can go over here and find the LCD the same way we have in the past. 7x is completely factored. 14x is 2 times 7 times x. Our factors are 2, 7, and x. We can only use 2 ones. 7 shows up once here and once here, so we only use it once. And x shows up once here and once here, we can only use it once. So that is 14x. Now we're going to multiply the top and the bottom by 14x. When I do that, I get 3 over 14x times 14x, all over 6 over 7x times 14x. I can cancel here. X cancels x. 7 goes into 14 2 times. All I have left on the top is 3, and on the bottom I have a 12. Now I can simplify that. 3/12 is 1/4. For this problem, I have two denominators, but this one is not factored. Let's go ahead and write the problem where the denominator is factored. Now, can you see that the LCD is y plus 3, y minus 3? We'll multiply by y plus 3, y minus 3 on top and bottom. Now, when I multiply, I get y over y plus 3, y minus 3 times y plus 3, y minus 3, all over 1 over y plus 3 times y plus 3, y minus 3. Now I can cancel. Y plus 3 cancels, y minus 3 cancels, y plus 3 cancels, and I'm left with just a y on the top and a 1 times y minus 3 on the bottom, so just y minus 3. For this problem, recognize that the denominators here are 1, so the LCD between 1, x, 1, and x is x. I'm going to multiply by x over x. When I do this, I need to make sure that I distribute that x through both of those terms, since I have a binomial in the numerator and denominator. So I get a 4 times x minus 1 over x times x all over 4 times x plus 1 over x times x. That gives me a 4x minus the x's cancel, I have just 1, all over 4x plus the x's cancel, I have just 1. Again, a problem like this can seem intimidating, but just pull it apart piece by piece. My denominators are all x plus 1, so this is really quite easy. All I need to do is multiply by x plus 1 over x plus 1. Remember, you need to distribute this to each fraction within the complex fraction. So I'll have 3 over x plus 1 times x plus 1 for the numerator, and in the denominator I'll have 4 over x plus 1 times x plus 1 minus 1 over x plus 1 times x plus 1. Cancel what you can. We get a 3 on the top. On the bottom, I get a 4 minus 1. And that's just 3 over 3, which simplifies to be 1. In this problem, I have m's and n's. I need to find the LCD so that I can multiply the top and the bottom of the complex fraction to simplify. Let's look at m squared n and m n squared. This is the same as that denominator. This is the same as that denominator. So these are the only two denominators I'm working with. I have factors of m and n. M is used twice here, once here, so I'll use it twice. N is used once here and twice here, so I'll use it twice. That means I'll want to multiply this fraction by m squared n squared over m squared n squared. Remember, you need to distribute it to each fraction in the complex fraction. This means I'll have 1 over m squared n times my m squared n squared plus 1 over m n squared times m squared n squared all over 1 over m squared n times my m squared n squared minus 1 over m n squared times m squared n squared. Now let's cancel what we can. M squared cancels. n cancels one of those n squares, so I just have an n there, plus m cancels one of the m's, n squares cancel, so I have just an m there. In the denominator, the m squared cancels, and one of the n's cancel, so I have an n, a minus, one of the m's cancels, and both n squareds cancel, so I have just an m. And that covers that section. Go ahead and try the homework. Please let me know if you have any questions.